Alright, so today we're going to be doing 10.1, which is simplifying rational expressions. So in order to do any of that, we need to know what a rational expression is. A rational expression is a ratio of two polynomial expressions. And a rational function is where we have a fraction with two polynomials, one of which is in the numerator, one of which is in the denominator. Okay? With that, we are going to call the top one typically P of Q, and the bottom one is typically going to be Q of X. Okay, P of X and Q of X, where we call our numerator and denominator. Okay. Of course, you cannot have 0 in the denominator in math. Okay, so the reason that we have restrictions, which you're going to see, is because we cannot have 0 in the denominator. Okay, that's the reasoning for that. So, step 1 is you're going to have to factor the numerator and denominator. So if your factoring skills are still lacking, you do got to practice that on your own time, because we are not going to review all of the factoring skills every single time we do a problem. Okay, I'm going to factor stuff, and if you guys are like, I still don't understand how to factor, I don't understand where this is coming from, I'm going to refer you to an old video because we just don't have time to also learn factoring while we're doing this. Okay, just keep that in mind. I'm not doing it to be mean, we just have only so much time in this class to spend. You're going to cancel them out, and then you're going to be left with the result. Okay. So best way to do it is just to try it. Step 1. Both of these are what we call monomials, okay, single term. So these ones are pretty simple. First thing you got to do is figure out what restrictions we have. So we can't have 0 in the denominator. So we can't have x be 0, and we can't have y be 0 because that would make that denominator 0, right? Everyone understand why those are my restrictions? Okay. Now we're just going to simplify this. How many times does -6 go into 24? -4. What's going to happen with the x squared over x squared? Good. Now when you have the same base over the same base, you subtract. So what's 3 minus 2?
1.
But it's going to stay in the bottom because the bottom had the bigger one. Okay, whatever one has the bigger one to start is the one that keeps the variable in that case. Okay? Yes?
So it was 3 over 2, it'd be y.
Exactly. On the top. All right. Next one. So when they put a -1 power on something like this, that basically just means that that is the denominator of your fraction. Okay? So that -1 power means that is the denominator of your fraction. And once you make it the denominator, you don't need to write that -1 anymore. You've already addressed it. Okay? So now we're going to find our restrictions. A cannot be, and B also cannot be. Good, because that would make my denominator, which we cannot have, 0 in the denominator in math. Okay. How many times does 4 go into 8?
2.
Good. And then what's going to happen with the A's and the B's? Yep, it's going to be squared on the bottom, and then the B is going to be
On the bottom.
on the bottom as well, just one of them, right? Because we're subtracting. Yep. All right. Any questions about that one? Yeah, it's a huge pain. It's broken. We're trying to get it fixed.
I want to fix it though, don't worry.
What are you doing?
So, funny story.
Alright,
Talking about my academic success, right?
What?
I have Mr. Dorman on the other side of campus.
We're on record right
I
now,
know
so
it's
if you don't
late.
want it on the YouTube channel, you might want to wait.
Everybody, I was late on the YouTube channel. My name is Eli Grabio.
So they
I was
you need a
curious if I
pass.
could
Is
get a
that what you're
pass.
saying? Okay.
Yes, ma'am.
Okay.
That's kind of ironic you're talking about my academic success, though. I
Okay.
tried to explain it to him, but he didn't want to hear it.
All right.
He's an automotive, he can fix a door for
Exactly. I'm a pro.
You just popped in. You're like, I'm gonna fix the door tomorrow.
I got it. Don't worry about it. Thank you very much.
You're welcome. Goodbye. All right. Anyways, next one. Letter C. So for letter C, same idea. We have to rewrite it. When we have a negative power, that means it's in the denominator. Okay. So we're gonna rewrite it with this in our denominator. And then restriction. So x cannot be, and y also Now here's what people were messing up last period. Can z be 0?
Yeah.
Yes, c is okay because it's not in the denominator. Okay, you can have 0, it just can't be in the denominator. All right, so now that we simplify this, how many times does 5 go into 35?
7
times.
Good.
Let's go.
And then with the y's, what's going to happen?
Cancel.
They're gonna keep. They're gonna.
No, they're not.
They're not gonna cancel.
You're going to
Y2 on the
subtract
bottom.
y2 on the bottom.
Yeah.
The x, it doesn't have anything on the top, so it just stays on the bottom. And then the z, there's no z on the bottom, so they just stay where they are. Yes.
Why can Z not 0?
It's okay to have 0 in the numerator,
Right.
just
Well,
not in
would
the
that not make
denominator.
any sense though? 'Cause you're like, wouldn't it just still make the numerator 0 and you do 0 divided by?
You can do 0 divided by a number, and that's 0, and that's okay. You just can't divide by 0. It gives you undefined in the calculator.
Okay.
Yeah.
Can you go back to D?
Yes. And somebody else up front, you raising your hand?
Yeah.
Yeah, what's up?
Does it matter the order of the
Letters?
bottom?
It doesn't matter unless they say to write it in alphabetical order, which I've seen like very rarely on questions, maybe on the SAT. But typically on the test, if it's multiple choice, I will write it in alphabetical order. But I will not mark you wrong if it's not.
Alright.
Yep. Everybody understand the powers and everything else about them, though? Okay. All right. So next question. As you can see, this one's a little bit different. This one is a trinomial over a trinomial. So step 1 is you're going to have to factor the top and the bottom. So to factor the top, we're looking for factors of 10 that add up to 7. What do we got? 5 and 2. And then for the bottom, we're looking for factors of negative 10 that would add up to negative 3, which would be?
Wait, why is the x negative? I mean, negative
Hang on,
2.
too many things going on.
Sorry.
Yeah, this is going to be negative 5 and positive 2. And you're right, the 2 on the top should have been positive. Is that what you were saying?
Yeah.
Okay, I got you.
Thank you.
So does anybody have any questions about how we factored this? Sorry, there's a lot of distractions going on. Sorry, man. Anybody have any questions about how we factored this? Okay, so here the restrictions are a little bit different. If I were to plug 0 in here, this would be okay, right? Because 0 minus 5 would be negative 5, and that's not 0. But when you have binomials like this, you have to set each of those binomials equal to 0, and that's going to give you what your restrictions are, okay? Because that will be what makes that denominator 0. So x cannot be 5, and x cannot be what? Negative 2. Those are my restrictions. So the restrictions come from setting the denominator equal to 0, okay? Now, what your goal is to simplify this. Now, you can only cancel things out when it's multiplication, which is existing between these two. Do we have a common factor in the numerator and denominator? This one right here, right? So ultimately, my simplified form is going to look like this. Now, here's where people get tripped up. They try to cancel out the x's. You can't do that. You can only cancel when it's multiplication between them or division. You cannot cancel things that have addition and subtraction. They're married. Okay, you cannot cancel them. Does that make sense? Okay. Yeah, divorce is another type of math that you go into, okay? All right, any questions about that? Okay. So this one here, before we can factor it, we have to take out a GCF, right? What's going to be the GCF on the numerator? 5y. So we're going to take out a 5y. Good. And then we can factor it further, right? So factors of 3 that add up to 4. 3 and 1. Right? All over. The denominator is already partially factored, but for the other one, does anyone remember what we call this right here? Somebody said it, difference of squares, right? Anybody remember how to factor a difference of squares? It's y plus 3 and y minus 3. It's always the square root of that number, okay, and then a plus and a minus. Because if you were to FOIL this back out, you would end up canceling out the middle terms and just being left with y squared minus 9. You can test it out too. All right, so we get here. Now, you can set each one of these denominators equal to 0 and solve to get the restrictions, but I can probably just look at them and tell, right? Y cannot be what? Good. Y cannot be negative 3 or positive 3. So if you want, you can write it as y cannot be plus or minus 3, or you could write it as them as separate. Either way is correct, okay? Whatever one you want to do is fine. So if you like to write them two separate ones, that's fine. Or you can write it together. Both are the same, both are correct. Everyone good with that? All right, now from here we want to cancel out anything we can cancel out, which is what? Good, the y plus 3, and that's all we can do. Any questions about that? All right. For the last one, what can we factor out of the top?
4.
Which leaves me with? 3 minus 1x, or x, good. And the denominator is going to factor into x plus 3 and x minus 3. Difference of squares. So what are my restrictions? Can't be plus or minus 3. Now here's where things can be a little more tricky. Subtraction is not commutative. Why does that matter here? Can we cancel these two out? Not the way they are. There is a workaround we're going to use. But you can't cancel them out the way they are because the first one is like 3 what's 3 minus 5, for example? Negative 2. What's 5 minus 3? 2. So they're similar. They have a relationship, right? But they're opposite signs. Yeah, absolute value kind of idea, right? So they can be canceled out, but what do you notice we're going to have to pull out of one of them? A negative. So let me explain. If that doesn't make sense, just watch the algebra. So I'm just going to look at the numerator. I'm just going to rearrange the two terms. So I'm going to write the x first and then the 3. So I just rearranged them. Everybody understand how I did that? Okay. Now from here, what can I factor out of that numerator now? I'll factor out a negative 1, right? So that leaves me with this, which I can simplify to become negative 4 times x minus 3 over whatever we had originally. So what you're going to notice is you don't have to do all that steps every single time. Just understand, if you want to cancel these out, if they're opposite directions, you have to make the numerator opposite sign. Okay, basically multiply it by a negative 1.
Wait, so if instead of like at the beginning, instead of factoring out 4, if you just factor out a negative 4, could you just skip all of that?
Yeah, sure. It's just sometimes hard to know when you're going to need to in the beginning. You know what I'm saying? But yeah, you're right. If you had factored out a negative, that would have fixed it too. Any other questions about that one? All right, I'm going to hand out the homework. You should probably finish it.